Right, some of you may remember this from a previous video, which is going to appear here or here. I'll link to it, where we actually did a teardown of this chassis. All we're left with is a nice box. Well, it's a box. Extra holes in it which need to be modified, but I am going to completely go through this, tear it down, and show you that we can turn this little old transistor Fender amp into something that is actually quite nice. Okay, here we go. Just to start off, here's a picture of the Fender Champ 5F1, possibly the most popular Champ model to actually model. Now, with the 5F1, it's very basic. It actually uses only 3 valves. You have a rectifier tube down at the bottom here, which you can probably just see at the bottom of the frame. Then you have a 12AX7 or an ECC83, depending on whereabouts in the world you live. Over here, they were all ECC83s. But I imagine over in the United States, they were 12AX7s. Exactly the same thing. It's a dual triode valve in one single bottle. The circuit diagram obviously shows them as 2 separate halves. And then for an output tube, you have a 6V6 GT, which is a lovely little valve. Produces between 4 and 5 watts, depending on how hard you drive it and how you bias it. And it's actually quite a nice little valve. Produces some beautiful sounds and is slightly warmer, in my opinion, than the EL84, which is a common British valve, which has a more chimey sound. The only problem I've had with this particular circuit, I've got the final valve, I've got the output transformer, I've got the jacks, I've got pretty much everything on here as stock items, whether they be new or whether they be old stock. The only thing I can't get is the transformer and the rectifier valve. I haven't got those in stock. Now, in Europe, the most of the stuff that's left to purchase is all 6-volt heaters, not 5-volt. The 5Y3 GT uses direct heated rectification. The 2 plates in the 5Y3 are heated by 5 volts, and the high voltage wire is fed in and rectified down this path. So what I've actually got, and let me move this circuit diagram and do this magic trick where I fold that over and put that, let's just put that back under the camera, and you should be able to see it if I can hold it down. What I have, you have the mains coming in again, you have the same fuse into the transformer. Rather than having a 2-pin cord, you've got a 3-pin cord with the earth wire going straight to the earth on the chassis. I haven't yet decided whether I'm going to use a mains filter with an IEEE type socket, the 3-pin kettle lead sockets here, whether I'm going to wire a cord straight into the back, as would have Fender done originally. The 3-pin cord is quite a convenient idea, but I don't know. Ifs and buts. What I am going to do, though, I do have a transformer that actually has a 6.3 volt heater winding, and this valve here, instead of being a 5Y3, is an EZ80, and that was salvaged from either a tape recorder or a radio or a record player or some vintage piece of kit that no longer was viable as it stood. So what I plan to do is use this assembly to provide the same high voltage rectified DC output as the original diagram, which is why I've produced this lovely little magic trick flap and kept the circuit diagram pretty much exactly the same. This part of it is very straightforward, and I have lots of the bit. Well, I have all the bits in stock for that, as are these capacitors here. These are the main power filter capacitors. Can get them either as an all-in-one, or in most of the Fender Champs that I've seen and all the pictures on the internet, they are actually separate paper capacitors, which by this time will have rotted away. Now, what I have done is I have marked on the corner here heater pins, just so that it's easier to follow through. On the 12AX7, you've got 4 and 5 together at 6.3 volts with pin 9 as ground. Most circuit diagrams don't show the actual heater pin values. They just say, well, they assume that you know where the heaters are going to go. I prefer diagrams where you write them in, and what I will do at a later stage, I will write in all of the pins for all of these different connections, so that when we refer back to the circuit diagram, it will make sense to you. The 6v6 GT, pins 2 and 7 are the heater pins on that particular valve. Now, with regards to this new transformer, is it man enough for the job? Well, I did do some investigation into some of my old books, and if you read the data books, which I do quite frequently when I deal with valve equipment, there's first of all, there's the Mullard one, and one of my RCA tube manuals. These books have the data on pretty much every valve that was available at the time, and a lot of other information besides. So rather than bore you with facts and figures from those books, let's put them to one side again. Let's go straight to the pertinent details, which are, let's remove that so that it doesn't confuse you. There we go. Which are pretty much what I've written down here. What do each of these valves require to run? Starting at the top, the 6v6 GT has a heater voltage of 6.3 volts. Well, okay, not a problem. It needs a current of 0.45 amps, or 0.45, 450 milliamps. As a heater current, which is not too bad for a power tube that produces as much power as that. The EL84 actually uses almost double that. It's almost an amp. So you're actually got quite an efficient heater on the 6v6 GT. And at full tilt, when you're cranking it right up and you're making lots and lots of guitar noise, the maximum plate current, or over here in England we also say the anode current, is 47 milliamps. So these figures are important, but not so important that you need to panic about them at this stage. It's not a lot of complicated maths. I'm not going to do a how you work out everything series. At this stage, I'm just building the amplifier and I'm giving you basic information. If we move on to the 12AX7, the heater voltage, now because it is two separate tubes, as we saw on the other diagram, you can either run it on a 12.6 volt heater or two 6.3s in parallel, which is actually quite a common way of doing it. The valve is actually so useful that it can be run on either, that it's just a standard valve for pretty much everything you'll find. The heater current required is 0.15 of an amp, so 150 milliamps. But that is per side. So what you've actually got to realise is it needs, if you're running it at 12.6 volts, it needs 0.15 amps. But if you're running it at 6.3 volts, which is the two sections together, it actually draws 0.3 amps, which is, again, not too high a drain. And this is actually the surprising one. The maximum plate current, again the anode current required by that valve, is 0.006 amps or 6 milliamps. This crossing out is where I put the decimal point in the wrong place when I first wrote this down. So I make mistakes too. I'm not perfect. I know I'm not. So that's the requirements of the one tube there. So then we go on to the actual rectifier itself. That also runs on a 6.3 heater voltage, and the heaters will draw 0.6 of an amp, 600 milliamps, for an EZ80 valve. Now I did look at the next valve up, which is an EZ81, which requires more current but can supply more current. The EZ80 valve can do a maximum of 90 milliamps. The EZ81 can do 160 milliamps, which is almost double the capability. It's like having a car that can do 50 miles an hour and then another one that can do 100 miles an hour. It's just got more capacity to do work. So what I've done here at the bottom, I've worked out the total heater current. So the valve number 1, which is in this case valve number 1 plus valve number 2 plus valve number 3. In total, it will draw 2.05 amps from the 6.3 volt heater line. So when you add up this one and this one and this one, you get the total current drain. So V1, V2, V3, 2 amps, which is actually quite a small current drain on a transformer. When you go down to the next stage, the total plate current, what you have here is the complete amount of current that you need on the high voltage line. So again, V1A, which is the first half of the 12AX7, remember it's in 2 halves, plus the second half of the 12AX7, plus V2, which is the power tube. In total, at flat out, these things will draw 0.059 amps or 59 milliamps. Now, going back to what I was saying about the 2 different rectifier tubes here, the EZ80 is capable of 90 milliamps. So there's no point in actually going for something that has a huge power transformer with a huge rectifier just to power 59 milliamps of high voltage. It's just a waste, and also it will actually change the sound. When you use a rectifier that is running fairly close to its edge, 75%, 80% of its current rating, you do get what known as sag on the high peaks in the music, which change the sound slightly. And solid-state rectifiers don't do that, which takes away some of the character of a rectified valve amp. So I prefer using valve rectifiers simply because they just sound warmer. They have that more vibrant, more lively feel. So that's all the maths I'm actually going to get involved in on this amplifier. Everything else has already been worked out. From 1952, I believe the first Champ 5F1 came out, right up until its revamping, I think, in 1964. So Leo Fender's already done the homework, he's done the maths, he's done everything. All we have to worry about is, can we get the bits? Now, if you're going to buy a transformer, you need to know what your total heater current needs to be and what the plate voltage, the plate current needs to be. Plate voltage is also important, but when I'm doing this from scratch with bits I've got, I really have to take whatever I can rather than specify a particular transformer. So, with no further ado, let's take that away and actually show you what I have got, which came out of a tape recorder. There we have, let me just tip it that way, We have a transformer. The capacitor I'm not going to reuse because I don't need to in this particular amp. And we have an EZ80 rectifier, and this one is a genuine Mullard one. I do actually have other genuine Mullard EZ80s, as this one is all on one piece, which came out of, as I say, either a record player or a tape deck, or reel-to-reel tape. It wouldn't have been a tape deck, it would have been a reel-to-reel unit or an old stereogram, anything like that. It's just simpler to keep all the bits that were together. If I turn it over, you can see that I've already marked what the cables do. Do that when I take it out. As you say, 6.3 volts, that's the heater winding. Now, most of the current required by this amplifier is actually in the rectifier. That's why I'm not worried about the rating on these wires here, because they're perfectly capable of running 2 extra valves. The unit that this came out of had about 5 valves on it, so I know there's plenty of current available to actually do what we want to do with this particular one. These two here, the blue and the black, are the high voltage wires from the transformer. This black one is the B+ wire that will go off to the filter capacitors. In this case, it's already going to the filter capacitor. But as I say, we're not going to be using this one. We will use a different one. If I turn it over, you can also see what I get out of the thing. I did do a test, and you might want to look at my earlier video on how to find out about random transformers that you pick up from here, there and anywhere, how to test them safely. What I found with this particular unit, 240 volts AC input, which are on these two wires. This is the AC, the mains input. It gives me about 360 volts DC without any other load on it. So out of this wire that this is actually attached to, there is 350 volts DC, and I've put off load. That will drop once you connect some sort of load to it, once you put the extra valves, capacitors, resistors and everything else in line. Now, must say about safety, there is only one caveat when you play with valve amps. 360 volts DC will kill you. If you don't respect electricity, please don't do this. Please don't build an amplifier. It's just paramount that you work safely. What you should do is you should actually look at a few YouTube videos, look at a few books, and find out how to work on high voltage electricity if you've never done it before. Ask advice. I'll try and give some advice. My own preferred method is quite common amongst electrical engineers and electronics technicians, especially old ones like me, and that is the one hand behind the back, one hand in the pocket technique. You just keep one hand off the bench. You never use two hands on any live circuit. Obviously, you're better off not working on live circuits at all, but if you do, you need to keep yourself off ground, and you need to not touch anything that could kill you. One hand in the pocket. If you worked with both hands on something, you're providing a lovely path from one side of your body to the other, right across your heart, and that is enough to stop it. And it's not a nice thing to think about, really. I'll have 100 engineers then put a comment at the bottom and say, well, I had a shock from this and I'm still here. We were all lucky. I've had shock from high voltage electricity. In fact, I have had one from considerably more than this particular voltage, and it hurt. It hurt for days. Please, safety first. Right, enough of the rambling. So, what are we going to do? We've got a transformer, we've got a valve. Now, here we have the Fender Princeton layout. If I can just squeeze that under the tripod. This is basically what we are going to copy. Here is where the transformer is actually mounted on the top of the chassis, and here are really the wires. Now, this was drawn many years ago. You can find this diagram on the internet. Just do a search for Fender Champ 5F1 and you will find this drawing. Do a Google image search. There is absolutely no copyright left on this at all. It's all over the place. It's the simplest circuit you could actually want. So I can go through it. Here we have the rectifier valve, which we're going to use that one there. That's the rectifier valve. This is the 6V6 power valve. This is the 12AX7 preamp valve. As you see, it's marked up with a speaker jack. You also have your two input jacks here. Looking through, you have your volume control. This particular amp only has one control on the front. Now, Fender did have a switch on the back of the volume control so that when you turned it all the way down, it went click and switched off. I haven't got one of those. So what I am actually going to do is I will be putting a separate switch on the front panel. Now, also, the advantage of actually moving that from there to over here is that you keep all of the mains away from your signal lines, which can reduce hum. And the last thing you need is to have an amplifier that's sitting there going in the background while you're trying to play a quiet passage, and all you can hear is the amplifier humming away rather than the music you're creating. So moving that over here will make a difference to the hum, I hope. Other people who've made these amps have said it's the best way of doing things. So that's what I'm going to do. I'm going to move the switch to a separate switch. Here we have the actual layout of the circuit board. Now, the circuit board can be made of, well, originally Fender did it with an eyelet board with the same eyelets you'd find on shoes or jackets. And they were made of brass, and he basically soldered them through a piece of very stiff. It was like cardboard. It was a compressed paper type material, and then underneath that he put another piece of material, and it was screwed down to the board. I personally think that's a bit old-fashioned. So I'm not going to copy that method. What I am going to do is I am going to use a piece of Paxolin, which is just again, it's an old-fashioned composite material, but this is a scrap I had left over from something else. You buy it in sheets from eBay, or if you want to, you can use fiberglass board. Can get plain fiberglass board. In fact, I've got one for another amp, which I've been working on. There, that is quite thick. Again, you can buy this on eBay. You can buy all of this on eBay, all the components on eBay. You don't have to be like me and have a complete stock. You can buy pre-made kits. I also know that there's a company just outside Cambridge who supply Ptfe Boards, which again are very, very good. They're an insulating material. All of these are non-conductive, and when I go through it, you'll see how I build these up, but this is going to be repeated in a style on this Paxolin board. If I show you the back of this one quickly, you can see that because it's not a printed circuit board, you do actually have to add in your own jumper wires, which on the layout are marked with the dotted lines. And all you do is you put the dotted lines in. You can put them underneath the board. If you really want, you can put them on the top of the board. It's up to you. But we're not going to do it that way. We're going to do it roughly like this. So what do you do to start with? Well, the first thing you need is you need something to make your board out of. What I like to do when I start a build is I'm going to lay that there. I'm going to move this across a bit. Let's see if I can, and keep it in shot for you. I'll just slide it that way. Right, okay, yes, that's just the power transformer. So what I'm going to do is I'm going to put this there for a moment. Right, okay, so there's the transformer, there's the valve. Yep, we know we've got those. Right, okay, let's put those to one side. We've got the transformer and the valve. And then I'm going to get all the other bits together. So what do I need? Well, I need a socket for each of these valves. So there's one for the 12AX7. Let's turn it that way up. There's one for the EZ80. There's one for the 6V6. So let's put that there. And then to follow on with that, let's go. I need a fuse holder. So fuse holder, that's to go there. Pilot lamp, I am waiting for eBay to supply, which is coming in the post, as they say. We need a volume control, and just to make it pretty, I actually have a knob that says volume on. I also have the switch that I said I was going to put in and move over here. The input jacks I'm going to salvage from this, which came from an old reel-to-reel tape recorder as well. Let's see if I can get it in shot. There we go. I'm going to move the transformer out of the way so that that can get closer in shot and you can still see the layout. So as you see, there's 4 jacks on there. It's still attached to a metal plate. The metal plate will come off. And then we go to the components. So following it through on the layout, we've got a 16 microfarad capacitor rated at 450 volts. Now, I'm not going to put these the right way up at this stage. I'll do that when we go through the build. So 1 capacitor. Then we have 2 8s. Now, these days, 8 microfarad capacitors are not common, so I'm actually going to use a pair of 10s. So there we are. They're all rated at 450 volts. That is actually important because if you underrate them, they tend to explode. So you're better off actually getting that bit right. I've also sorted out all the relevant resistors, but rather than sit here and bore you by putting them on in the correct order, I'm going to put one there that will represent the 470, but that's not a 470, so all those other engineers who know what the colours are, by all means, you know, criticise me for doing it this way, but this is just a quick count up of the components. There's a resistor here, which will be there. There's another resistor, which will be across that capacitor there. There is a... going further across this way, there is another capacitor, which is that one. So that's there. Then we have 2 resistors. 1, 2. So they're there. Then we have another capacitor. Then we have 2 more resistors, which go down there. The reason I do this is just to make sure that I can fit everything on the piece of board that I'm planning to work on. We have 1 more capacitor there. So you're knocking everything all over the place here. Obviously, when you're working with it properly and doing the soldering, it will stay in position a lot better. Then we have 2 more resistors together up here. and we have one final one at the end there. Now I've got two left in my hand because there's also one between that capacitor and that resistor, so that counts for that one. And there's also one just up here which is off the board, which comes from this pair of resistors here. So let's just mark that up one like that, which would go to the input jack. So now I know that all my components will fit on this piece of board, and I've got everything I need to actually start the amplifier. Now I haven't put my output transformer on there. Let me just see which one I've got handy. Right, there we go. One output transformer. There are different specifications of output transformer. You can buy big, little, push-pull. You can buy, well, in this case, we need a single-ended transformer, which is what this is, I think. Let me have a look. Those two are on the same one. So there's input. This one, yes, they're both on the same. So this is a single-ended transformer because you have two wires going in, two wires coming, although there are three soldered. That would have come from somewhere else on the board. Again, salvaged from the same tape deck as the original transformer that I've shown you. So there we have all the parts ready to build. The only thing I haven't put out is the chassis. I did get the chassis custom made. I did buy it in new, and it was made by a chap who advertises on eBay, and I will link to him on the video somewhere, probably here or here or maybe here, or there'll be a link. So somewhere there'll be links. I think we've gone far enough for this today. I think I've bored you senseless enough. When I get to part 2, we shall actually start to actually make the circuit board and just check the fit of everything in the chassis. And you should be able to follow through from that. Thanks very much for watching. Hope it's been good. And if you do like the video, please wait for the next one. If not, just tell me you don't like it, and I'll probably not bother carrying on. I'll still build the amplifier. Somebody might like it. But please subscribe or leave comments. Everything's welcome, good, bad, indifferent. If you don't like my style, well, tell me what I can do to improve it. Thanks very much. Bye-bye.